Hello friends, welcome back to another session of Kubernetes. In this session we will learn deployments. Deployments is another object inside Kubernetes similar to pods, namespace, replica set. In our last session we are done with we are done with replica set. So the replica set will hold pods, multiple pods will be there. We will define how many replicas we want, like 5 pods, 6 pods, 10 pods we will define in the file, and later on we can scale up, scale down also. So replica set will not do anything, it will just manage the pods for high availability. Okay, so similar to replica set, deployment is another object, but deployment will manage the replica set. Any deployment, replica set will be there. One deployment will have one replica set, and that replica set will manage the pods. Okay, so from this diagram you can easily understand. Deployment will have a replica set. Replica set will have pods. Like currently in this diagram you can see 4 pods are there, and each pod will have a one container, and container will have the applications running. Okay, so replica set, what replica set does actually? Replica set ensure that a specified number of pods, replicas are running at any given time. I say 5 pods should be up and running for this application at any cost. If any pod is failed, create another pod, but 5 should be up and running. Due to some reasons one pod is failed, even the node is failed, node is not responding, the cluster node itself is down, then whatever the pods is created in that cluster, it has to be created again in some other node. So that is the responsibility of replica set, that ensures that the specified number of pods should be up and running at a given time, at any given time. Okay, so that is replica set. But what is the job of deployment in that case? As you can see, deployment name itself suggests we have to deploy the application. So while deploying the application, we need to make sure that there should be zero downtime. Downtime should not be there. Downtime should not be there, and application will be highly available. So what deployments will do? Deployments is another object in Kubernetes. It is a high level concept that manage replica set and provide declarative updates to pods, along with other useful feature like rolling update, rollback. It is recommended using deployment instead of directly using replica set. Directly we should not use replica set, because application deployment you cannot do using that one. Very difficult it will be. Suppose you have created one replica set, but you want to update that application, like new version is released, you have to deploy that also, but you don't want to shut down the previously running application. So with the help of deployment, you can achieve this one. With zero downtime you can update your application. Even you want to downgrade, you can do it. You want to scale, you can do it very easily with the zero downtime. Okay, so this has a two deployment has a two features, that is, one is rolling update and a rollback. Okay, so and deployment has a two types of deployment. two types of deployment for new version release for the application. So whenever you are releasing your new version of the application, you have to deploy that application. So how will you deploy? Whether you first shut down the the already running application and then you start. So there might be some gap between the startup and shutting down and start up the application. There might be. Anyway, it will be in minutes or seconds, but downtime will be there. Using Kubernetes deployment object, there will be zero downtime. How it will be? So this has a two features for deployment. Two deployments types are there in deployment. One is recreate deployment, another one is a rolling update. Recreate deployment and rolling update. What is recreate? Recreate, this approach delete all the pods from existing replica set and then create a new replica set. See, suppose you take this diagram. First, my application version 1.0 is up and running. I have started and it is up and running on the cloud. Next, new version of the application is released. Now I want to deploy that one. So how I can do? I can use either recreate deployment or rolling update. So suppose I am using recreate deployment. So what will happen in that case? First, this replica set will be deleted. Replica set deleted means nothing but it will delete the pod 1, pod 2, pod 3, pod 4. All pods will be deleted from this replica set, and then it will create a new replica set with the updated version. This is the approach that is followed by recreate deployment. Means it will recreate what? Replica set, but before to recreate it will delete the existing replica set. So if it is deleting existing replica set, it will delete all the pods first. Pod 1, pod 2, pod 3, pod 4, all pods will be deleted first. Then it will create a new pods 4 and replica set and new deployment. So if you use recreate deployment, there might be a downtime, because first it will delete all. Suppose at 11 o'clock all the pods are deleted, and when the first pod is creating, sometime it is taking like 2-3 minutes it's taking to create the pod. So in this between this time your application is unavailable, so there is a downtime. So if you use recreate deployment, this cause the downtime issue because of small gap between the deletion and creation of replica set. But if you use the second approach, rolling update deployment, in that case there will be zero downtime. This approach will how it will work, let's see from this diagram. So whenever the new version is released, you want to deploy, you executed the command, please deploy this one. So what your deployment object will do? Your deployment object will create another deployment object and create one replica set. Then it will stop one pod first. Pod 1 it will stop from the existing replica set. Then it will create a new pod in a new replica set. It will not delete all the pod at once. One pod it will delete first, then create one pod, then delete the second pod from the old replica set, and in the new replica set it will create the pod 2. Then Kubernetes will delete the pod from old replica set, pod 3 will be deleted from old replica set, and then Kubernetes will create pod 3 into new replica set. So like that, all pods one by one, first it will delete, first it will create, first delete, then create. So like that there will be zero downtime. Your application will be up and running always. Because you are not deleting all the pods at once. You are deleting one by one. You are deleting one pod, you are creating also. Once the pod is deleted, you are creating new pod with the latest version. Then then second pod will be deleted and second pod will be created in the new replica set. So like that you will get your new or latest version of the application up and running with zero downtime. Okay, fine. So this is called rolling update. And default type is rolling update always. Recreate, it is not default. If you specifically define, I want recreate deployment type I want recreate, so it will follow that one. But by default, if you don't specify, a rolling update deployment will be taken by default. Okay, fine. So you can see the advantages of deployment. Will give zero downtime, and you with zero downtime you can upgrade your application, you can update your application, you can deploy the latest version of the application, and you can also do rollback. Suppose in the latest version some issue came, suppose old version was running successfully, you are trying to introduce new feature into the existing application, so you released a new version, but some issue or some problem, some bugs came into the new release. So what you can do in that case, you have to undo, you have to roll back the last update. So that you can do using rollback. You will see that one. So this is the another advantage. Zero downtime is the one advantage of deployment, and you can do the rollback also. You can do the scale up, scale down also. If you are using deployment, then you cannot do scale up, scale down using replica set. You have to use deployment to scale up and scale down. If you intentionally do scale up, scale down, it will not allow. It will not do at all, because replica set is managed by not you. Replica set is managed by deployment. So that's why the operation, whatever you want to do, you have to do with deployments only. If you are trying to delete the replica set directly, you cannot do. You have to delete deployment, then only replica set will be deleted. Directly if you are trying to delete the replica set, it will not do, because that replica set will be handled or managed by deployments. Okay, fine. Now next is the YAML file. Like what will be the YAML file and how it will look like. So I will show you here. So this is the YAML file. This is the YAML file for deployment. API version apps v1, same as replica set. Okay, kind. Now kind is in the previous example, kind was replica set. Now kind is deployment, because this is a deployment. Now you can tell the name of deployment. In metadata you define what is the name of deployment. My web app is the name of deployment. My web app deployment. Specification, under specification, what you have to tell, you have to define the definition of replica set. As you can see in the diagram, deployment will have replica set. Deployment will manage the replica set, but extra feature of deployment is it will do auto scale, it will do zero downtime. If you want to upgrade the version, or you want to roll back that one, or you want to scale, you can achieve that using deployment. Even scaling also you can done through replica set, but if you are using replica set inside a deployment, you cannot directly do replica set operations. You have to use deployment only. Okay, fine. So specification, this specification defines the replica set definition. Okay, there you are telling, first thing you are telling rolling type, a rolling update, which type of deployment you want. Either you want a rolling update or if you want recreate deployment. You have seen we have two types of deployment, either recreate or rolling update. So rolling update is the default, and here also I am taking rolling update. But if you want to use recreate, you can use a recreate also. You have to just give here a recreate, it will be follow, but you no need. By default best is a rolling update because of zero downtime. You want zero downtime. Okay, replicas, it will tell how many pods initially it should have. 1 2 3, how many, that you have to tell in replicas. So currently I am saying at startup type it should be 5 replicas, 5 pods should be there in replica set. Okay, selector, that will be used for filter operation, or to match the pod. Suppose whenever you deleted the pod intentionally, how the pod will be checked whether this pod is has this pod should be 5s only, using match labels. This label it will match, your Kubernetes will match this label for deletion and creation. Suppose by intentionally you deleted one pod, but that pod is managed by replica set, and replica set says that whatever the pod you are defining, that should be up and running at any given time, but you deleted intentionally that pod, so it has to create that pod again. So it is checking the label. For this label, how many pods are there? 5 are there, 5 is expected. Okay, you deleted intentionally one, again it will create again it will create a pod who has this label. It is giving guarantee for the defined pod numbers. Okay, so this is a label. So this label pod and the replicas and both pod label should be same, that's why it is same. Okay, next specification. This specification will have the pod definition. This specification define the pod definition, but this specification define the replica set definition. Okay, fine. So here just simply you have to tell the name of the container, like this is the one container. You can define more than one container also, but I want currently, for example, I want here one. What is the image? What is the image of that container? Yeah, this is the image. Resource limit, memory, how much you want to use, CPU, how much you want, like that. If you delete it, it will okay, but keep it because default it is generated. Port, what is the port number of this server? 5050. That's it. So this is nothing but a YAML file that can be used to create the deployment. Okay, so next what we need to do, we need to store this file to strategy. Defines the type of strategy. We have seen strategy. Which strategy you see here, which strategy you are following, rolling update, or you can use recreate, whatever. By default it is rolling. If you don't define this strategy, if you delete this one, also work. By default it is taking rolling update only, but how you will specify explicitly, that's why I given here. It is better to specify to be more specific, more readability. Fine. Okay, so we can store this file. What we need to first so first what we need to do, we need to store this file to your server where your control plane is running. Okay, so let's start the EC2 instances. Even you can use, instead of EC2, if you want to use Azure, you can use, or if you want to use Google Cloud Service, you can use. Just there is some UI differences there, like if you are taking some system on a rent in AWS, they are calling it as EC2. In Google Cloud, some different name they have given. Azure, they have given some different name. That is, these all are the cloud services. These are the cloud services. You can use any of the cloud services. Way of connecting in Linux is same how we are doing. Okay, so let's connect your manager node, copy the IP address and connect here. Yes. Yeah, it's connected. So now what you need to do, you need to store this file, you need to store this my deployments.yaml file first. Okay, so what is the IP address? This is the IP address, and just copy this file. Okay, file is copied. Let's see. Yes, other files are deleted, like my pods, my namespace, my rs, that I deleted. I deleted all those files. To be very clear, this one, that's why I given here. Okay, now first thing, kubectl dot get pods. How many pods are there? Oh, still it is terminating the old one. Okay. System is very slow. Get rs, get replica set. There is same problem. Okay. So what I am checking first I am checking how many deployments are there already. Are there any deployments? Okay, let me resolve this one. Sometime it did work, sometime it's same problem. Okay, hope it should work. Before to creating deployments, I am checking get deployments. How many deployments are there? I am getting. Still it's not. Okay, so it is telling no deployments. Okay, very, sometime it is working only, sometime it is stopping. Okay, so get deployments. So there is no deployments currently, no deployments. Okay, and replica sets, if you check how many replica sets, there is no replica sets, because, and pods, these pods are there, but that pods are deleting. You just okay, you don't consider this, just these pods are deleting. Fine, it will take some time, but it will be get deleted. Next we need to create the deployments using this YAML file. So simple, command is same command we are using. YAML file, in YAML file type is defined, kind is defined, like it is a namespace, pod, whatever. So here kubectl create from this which file, this my deployments.yaml file, and if you see the content of this file, so this is the content that whatever we have created here, whatever we have explained, the same. Okay, fine. Now the deployments is there, one deployment is there. Now you can see the deployments again. If you see the deployments, how many deployments are there? One deployments is there, my web app deployments. And how many? 3 out of 5 means what? In this deployments, how many pods are required? 5. How many are ready? 3. Available 3, and up to date 5. How many should be there? 5. Okay, again you check once again, 5. Okay. So deployments, so this is your deployments. Now get replica sets. How many replica sets are there? So there must be one replica set. Yes, one replica set my web app, and after my web app some unique number it is adding, so this is replica set. Now here also you see 5 desired, means 5 pods are desired. Currently how many pods are there? 5. Ready 3. Okay. Fine. You want to get the details of pods, you can get it. Oh, could be the reason. Not able to practice properly. Anyway, see. Okay, now pods are there. You see how many pods are there? Total 3. Before 3 terminating, leave that one. Other than that, 5s are there. 5 are there. Yes, 1 2 3 4 5. 2 are terminating. Leave them. That is the other pods. But 5s are there. 5 are there. Out of them, how many are running? 3 are running. You see, 3 are running. Okay. Fine. Get deployments. Clear this one. Deployments. So now you see 4 are ready. If you see in replica set, 5, 4 are ready. Okay. Now if you see the pods, now deleting is done. I think old one are deleted. 5 are running, 2 and 2, 4, and 1 is creating. So now if you see the replica set details, what it will be? See, 4 are ready now. Okay, one is in creating state. Okay. Okay, so 1 is creating, 4 are in a running state. Fine. Now if you want to describe, you can describe that deployment also. If you see the describe, yes, you can see, let me clear, it should be working. Okay, so you can describe my web app deployments also. If you see the description, it will give more details like name, what is the namespace, default namespace, when it is created, annotations, any selector, my web app is the selector, how many desired, 5, how many updated, total 5 available, 4, 1 is unavailable, 1 it is creating. Okay, Rolling update strategy 25% max unavailable, that is okay, leave it, we'll see this later. Image port, CPU uses memory, it is telling whatever we have specified in the file, same configuration it is taking. And okay, fine. Here it is telling in the history, if you see, this is the history where it is deployment controller scaled up, it's creating the scaled up the replica to 5. By default how many replicas are there? 5, because we have specified 5 replicas, you see here 5 replicas. Okay, fine. So we have described also, yeah, described is okay. Next, if I directly I try to scale, suppose currently how many are there? Total 5 pods are running. Total 5 pods are running. I want to scale, and I am scaling with the help of replica set directly. 7 I am saying, and it is telling scaled. Is it really scaled? No, it is not scaling. You can see here, observe clearly. First we checked kubectl get pods. How many pods are there? 5 pods are there. Then I tried to scale to 7 for the same replica set. What is the name of replica set? My web app deployment RS. No. I think replica set name. What is the name of replica set? Get RS. Okay, so this is the name of the replica set. Now try to scale this one. Try to scale this replica set. Whether you can do, okay, same, I think same name only. Same only, fine. It's not changing the name, same name it is taking, same only. Okay, so it is not scaling. If I try to scale again to 3, will it really scale? It is telling it is scaled to how many? 3, but it is really scaled? No, 5 are there already. Okay, it is not scaling. So what you need to do, terminating, but it will not be 3, it will be 5 only. Even if you tried to scale manually using replica set, using replica set directly, it will not terminate. It will be 5 only. See, others are pending. If you see terminating, other are pending, it means again it is starting. You cannot do it. If you really want to scale it up, then you have to use kubectl scale deployments and replica 10. Simply you have to scale like that. You cannot scale directly using replica set. Means any operation using replica set, like delete replica set, scale down, scale up, you cannot do it. You cannot do that also, because that replica set is managed by deployments. So definitely you have to do any operation using deployments. So you scale the deployment now. kubectl scale deployments, this is the deployment name, and I want to scale to 10. Yes, now you see it is scaled. And now if I try to execute, you can see here directly 10 came, but before it was some of the terminating, some of it is again pending states, because if you are trying to scale down, scale up, scale down, it is happening, but it is again creating. Even if you are scaled down, then it is creating. If you scale up, it will be deleting. It will not allow to your Kubernetes will not allow to do any operation using replica set if that replica set is managed by deployments. Okay, see now, only you see 10 are there. It's some of them is terminating, creating, it's okay, but it will maintain 10 only. And suppose now if I try to scale to 3, can I do it? Can we do it? So how many replica, give the name of replica set, kubectl dot get rs replica set. So this is the name of replica set, and try to scale down using replica set. Using replica set, try to scale down. Scale down to 3. So will it really scale down? No, you cannot do. It is telling, but it is not scaling. You see, 10 are there only. See, again I am scaling, but it is 10 only. It's not affecting anything. See, only 10 are there. It is trying to terminate, but again it will starting. You cannot do it. But if you scale down using deployments, definitely it will be scaled down. See, 2. Now what happened? No object passed to scale. No, it should be scaled. kubectl scale deployments replicas 2. Okay, clear it. This problem. Okay, so how many are there? 10. Maintaining 10, sum of terminating, sum of creating in pending state. You see, pending means it will create again. Now I will try to scale down using deployments. See, it is scaled down, and now you check. See, how many are there? It's how many terminating? 1, 2, 3, 4 terminating. Two are there only running. And if you see again, see now how many? 2 are terminating, 1 more terminated. Again check. Terminating. Will take some time, but now it will maintain only 2. We'll see. You will see it will only maintain 2. See, it will take some time, but it will just terminating. These 2 will be removed, will be deleted, because scale type is 2 now. You have scaled it. Okay, now you describe and see the description of deployment. In the history, it will add some more. See, first it was 5, then I scaled to from 5 to 7. I scaled, 2 more added, then I scaled 5 to 3, then from 5 to 5, 3, then to 10. 2 from 10 I directly scaled to 2. Okay, so this is maintaining the history also. Fine. So here, from here you can understand, you cannot do any operation on replica set directly using replica set command if that replica set is managed by deployments. Currently our replica set, this replica set is managed by deployments. Okay, which deployments? This deployment. So you have to make the operation on deployments only. Deployment my web app, this is the deployment. So scale up, scale down, you can do it. Okay, next, rollout status. Like currently, what is the meaning of rollout status? Let's see. Yeah, so just simply what it will give, it will give the status of what? Rollout status. Like what is rollout? Whenever the new version is coming, you are rolling out that one, so it will add in the history. So yeah, so it is successfully rolled out. Now you see the rollout history, release version, show the rollout release version history. That's it. you will see currently we have deployed only one version. Currently if you see, we have deployed only one version. Deployment apps, web app deployment revision 1, only one version we have deployed. And suppose now now we have one new version 1.1. currently our version is which one, which version we have deployed? If you see in the deployment 1.0, I have released a new version called 1.1. it's already there in our Docker Hub. So I want to deploy that now. So what will happen? Which strategy we are following? We are following rolling update. It means it will delete one pod, then in the new replica set it will create one pod. And how many replica sets are there? Cube ctl dot get rs replica sets. How many replica sets are there? One replica set, and in that one replica set 2 containers are running. Okay, now when the new version is released, I want to deploy that one. So how it will be, how it will happen? So your Kubernetes will stop the version old version one pod, then start the one pod of new version, and then stop the second version of the old version and start the new version of the new pod of the new version. So like that it will follow because of rolling update. So let's try to deploy the latest version. So update a deployment, simply just update the deployment. So kubectl set what? Image for what? Deployment. Which deployment? This deployment. See, kubectl set image for deployment. Which deployment? This deployment. What is the image? So this is my web app controller container. If you see, what is this one? My web app container. Because in this deployments, how many containers are there? You see how many? One container. So which container? My web app container. That's why the name is there. So my web app container. For my web app container, I want to update the image. I want to update the image. So which image? 1.1. Previously it was 0 or 1.0. See, now I want 1.1. Okay, let's do it. Will take some time because in system, you know, the system sometime it failed, sometime the system will work fine. So because of that one it is structing here, but let's wait. It will definitely either will give some response. See, you can see here deployments dot apps, my web app deployment image updated. So now you see the replica sets. How many replica sets? Okay, so it should create one new replica set. So do you think this the replica set is the same, that old one that we have used here, or it is a some different replica set? 85F4. What was the replica set name? Replica set name was 85F4 48FD FFD. So I think it is same only, not scaled, but it should be okay. So for that one, what you can do, you just simply describe it, or you see the history. Either you see the history, if it is there in a history, like currently there was one version, in history it should be 2. Yes, definitely it is scaled up, because currently we cannot access that application in browser, and we cannot see the version. If we see the version, it will definitely show the version there, like 1.0 1.1, but we cannot see. But from here you can be sure it is deployed, the latest version is deployed here, because at that time we were not able to execute that command, we were not able to see. Okay, fine. See, yes, now you can see, now it is maintaining 2 replica sets, Why? Because whenever you are doing new replica set, whenever you are deploying the latest version, it will create a new replica set, and from the old replica set it will delete one pod, and in new replica set it will create a new pod with the latest image, and from the old replica set, from this replica set it will delete, and in this one it will create. You can see this is our old replica set, this is our new replica set. So still I think if you get RS, if you do yeah, it will changing. See, it is doing what it is doing. Our old replica set was this one 85, new is 65. So from 85 both are running. See, both are ready, means both pod are running. Now what it is, what's happening, one pod is running from 85 from old replica set, and one pod is running in the new replica set. It means this pod inside this replica set, the pod is running with the latest version. Okay, try once. Okay, it will take some time, like it is deleting the pod from the one replica set and creating the pod in new replica set, creating a pod deleting the pod from replica set, from old replica set, and creating the pod into new replica set with the latest release. So one by one it is doing. And if it is doing like that, in that case there will be zero downtime, there will be zero downtime will not be there at all. Okay, yes, fine. You can do update. Let's try once whether both are running or still it is doing. If you see that get pods, I will show you get pods command. If you see the get pods, you will understand which one is it's something it is creating. See, total 3 containers are there now. It is running, 2 are running, container creating. So once this container will be created, I think it will delete the old one. Get replica sets again you do. Okay, fine. 2 2. Okay, leave it. It will do same problem again. So it will do. Okay, so this is all about the scaling rolling version. You can see rolling out status. Status means just it will tell the status. Yeah, it is rolled out successfully or not. It will tell. Yeah, it will tell. Yeah, either it will show you waiting. Yeah, still it is means rolling out is happening. Like the latest version is going, it is deploying. It means the latest version is deploying. Okay, fine. Fine. And kubectl rollout history. If you see the history, let me check it. No, I will show you it. Anyway, we need to do this headache. There is no option. No, still it is not working. Okay, get pods. Okay, yeah, it is taking time. Running container creating, might be creating container and will delete the other one. Okay, let it be. it will do. So next is okay, yeah, status. You want to see the status. So rollout status means, okay guys, it will not work like that. I have to find some other solution. I think like that it will not work. I tried, but I didn't get any permanent solution. That's why we are just okay. See, waiting for deployment. It is waiting for deployment. Why? If you see type Ctrl Z here, and if you see the get pods, you can see there one, it is container creating, see it's creating, and two are running. Might be one is running for old one, it will delete after this creating and running successfully, it will delete. Might be it is happening like that, it is not deleting first it is creating, then it is deleting, creating, deleting more. That will be more instances and high availability. Okay, fine. So it will do like that. And if you see the history, it will tell, yeah, one new version is there. Where is that? If you see the history, it will say, yeah, new version is there, currently two versions are there, you can see. And if you do undo, you can do that also. Undo means what? It will deploy the old version. Okay, leave it, you can try kubectl rollout undo. Which rollout? Suppose if you have seen here kubectl rollout history. In rollout history, it is telling version 1, revision 1 and 2. So currently which version is deployed? 2, because we have deployed this latest version, and previously which version was there? 1. So how if I want, if some problem came, due to some reason in the latest version, some bugs are there, some issue are there, and I don't want to deploy that now. I want the old version to be up and running now. So what you can do? Simply just kubectl rollout undo. If you do undo, it will deploy the old version, and it will delete all the pods of latest version. Very simple. Okay, I don't know whether it will work. Anyway, we need to do that again, then only it will work. Okay, you try that one. Clear it. Just undo, rollout undo, and then give the deployment name. Yeah, so means this command says that you are telling to your Kubernetes, please roll out the undo, please do the rollout operation undo on this deployment. I want the old version that was deployed before to this deployment. This is the meaning of this command. Okay, anyway, if it will work, it is good, otherwise leave it. Okay, or else try. No other option. I think we should use Minikube. If we use Minikube, it will Minikube is single node cluster. You can we can test our commands there without any problem. We'll try that, no issue. Undo, try to undo. I think it will do something, it will say. Let's wait. No, some problem. Okay, you leave it, you can try, it will work. Okay, next you can delete also. This is very simple, like it will delete this deployment. Like if the deployment is deleted, it means the scale and everything will be deleted, like replica set will be deleted, pods will be deleted, it will be deleting everything. Yeah, it is deleted. So anyhow, now this command worked successfully. Now if it is deleted, then can you get the deployments? How many deployments are there? There must be no deployments. Yes, no deployment, no replica set. Yes, and there should be no nodes, but some no nodes, not the nodes, pods, sorry, pods. How many pods? It's terminating. See, the pods are also terminating. Even the deployments is deleted, no deployments. Replica set is deleted, no replica sets, and pods are also deleting, because we deleted kubectl delete deployments. These deployments I have deleted. Okay, fine. It is terminating. See, status is terminating. It means the pods are deleting. It will delete it. Fine. Fine. Next topic is auto scaling, and auto scaling means what? Suppose deployments. What is the deployments? My web app deployments. Okay. So auto scaling means I want to scale automatically my pods. Suppose if you see you suppose you have 32 GB RAM, 16 core processors, and you feel whenever the load is reaching to 80% or 90%, you don't want to put more burden on that server, on that node. You don't want to put more burden. So what you should do in that case, you must have to create another pods in another nodes. So you just simply you have to create the EC2 instance, and you have to join that EC2 instance into the container, into the kubectl cluster, Kubernetes cluster, and then your Kubernetes will automatically create the pods into another nodes whenever you are reaching, like you say CPU percentage. If CPU percentage is reaching more than 80%, automatically do. But for that one we need to do some other installation. We will see this later. Okay, fine. So this is all about the deployments. Okay, and in the next session we will see services, because see, currently anyway, if the pods are running, or not running, you cannot access that application using browsers, because it's not exposed to the outside world. For that purpose we need to have a service, then only it will be accessible. So currently it is not there. Currently that service itself is not there, so we are not able to access that application. So that we will see in our next session. Okay, thank you and have a nice day.